we are really all honored that you are in and that you are able to give an extended academic lecture. Thank you for that. And I will say the floor is yours.
Thank you for the invitation of this speech. A little bit not common when we have to do it by video, but I try with my pictures to fascinate the audience. And I hope that is interesting to hear, to go with me, with my experiments, with my tests, also with my possibility to collaborate with architects. We need really courage to build with timber. And you have to learn what architects design. We try to build it with timber. I said once, what architects can design, I build it with timber. More and more, the design of architects is more complicated. We have freeforms, we have high-rise buildings, we have really a new way to go in the future with our timber. Unfortunately, I often work for the birds. In German we say, wir arbeiten für die Katze. Oder ich arbeite für die Katze. After 3 whiskeys, before the millennium was changing, I was in Paris and I met architect Nicolas Nomier, and his project is a tower to 200 meters of height. And at the beginning, we started to drink whiskeys. And after 3 whiskeys, I said, it's possible to build this tower. But after that, sometimes I thought the goals are a little bit crazy. Because at this time, it was not usual to build towers with 200 meters in timber. We didn't build not more than a model. In Monaco, we had a cable car station. It's a project from Shigeru Ban. The color of pink is the color of the Monaco house. And below you see the racetrack of the Formula 1 cars. And I was a little bit afraid if the Formula 1 pilots cross this cable car station, then they look to the top and they don't crash in the curve it's coming behind. But this cable car station was not yet built. One project I did about 2005 is a roller coaster in wood to an altitude of 130 meters. That was a world record at this time. I don't know if now we have a roller coaster which are higher, but this project was very special, but possible to do, but not yet built. A competition I did together with Shigeru Ban architects was the airport in Zagreb. It was the idea, the intention to build it with timber. And there were 5 architects, but also here we had only the second place. The National Pavilion World Expo from the World Expedition in Jeju in South Korea was designed with Shigeru Ban architects. It was also a competition, but without any chance. For Google, I had also a project in San Francisco with a dome with 100 meters of span and 4 domes. We tried to plan, but after the planning, the project didn't go further, and so we stopped this project, these studies. But for the preparation of this project, I developed a new connection system with only wood dowels and plywood and beams. They were curved on the side. It's a very simple way to build about a couple domes until I think 200 meters is possible, or 300 meters we can do when we have a good connection system. And my dream is to build something like that once in my life. Another competition in France from the Le Monde headquarters, together with Shigeru Ban, was very audacious with really timber construction was not easy to develop because the forces were very high, but also in this competition we had only the second place. Now I come to a project which was starting 2005 and ending 2010. And as the role of the architect, I think, is mostly, he is the inventor, not the engineer. But he works together with the engineers, and the engineers has to be a good servants. And normally the engineers are a little bit anxious when the architect has project. They go a little bit too far in the design, and they then bring architect back to a more simple construction. But I think that engineers has now in the future the goal to work really very good together with architects and overtake her ideas and so forth. This project was won in a competition of about 152 architects. It's a Centre Pompidou in Metz, and Shigeru Ban won this competition together with Arup. And I show you here these designs. And I met Shigeru Ban once in Zurich, then in Germany. I went with him to Germany, to the company Ammann in the South Germany, and we discussed this project. And for me, it was not possible to understand how I could design it, how I could do the static, and how I could do perhaps also the manufacturing. But after this meeting in Germany, I wrote a mail 1 month later, a little bit more than 1 month later. Yesterday we discussed and solved the construction with Mr. Gerhard Ammann and Bernhard Ritschler, we can build a roof without great complications. The costs are in your given area. But the problem was I didn't know how. I didn't know how that will cost. I didn't know nothing, really nothing. But the promoting of a project like this, that gives you the force to study and study and to find out a new solution. You must invent new connections. You must study new computer program and so forth. The problem in this project were the double curved, not board beams, really beams, because the span was about 100 meters from one corner to the other corner. Between there were some supports, it's clear, and to connect them, and also the drilling of these beams was at this time not solved. And the proposal from Arup to connect these beams were long screws about 1 meter and 20 centimeters length. And the problem is to integrate these screws in this packet of beams, because you never are very precise or to find the holes. So I had really a black hole in my head, but I had proposed the feasibility of the construction. Doubts about whether the visions set by the architect could not be outside the realm of possibility occupied me for more than 7 months, and it was really, really a hard time. Then I had the first idea to build it with a BSP system. I know very good because I do lots this system, and to weave the beams in this way. I met Shigeru Ban in Zurich 6 months later, but his remark was, you can perhaps not read that as in Japanese, that has no, I don't want a construction like that. Then I had to go on, and I had ants in my head, and the solution should be like that, with crossing curved and twisted beams and connected them at the cross points. But how you do the assembly on site, how you can form these beams, how you can do the static calculation, how you find the geometry of that. So I learned Rhino, and that helps me to design the geometry. And the geometry more and more was developed in my head. But then I had a special idea. I looked to the in a railway station up and saw that there is a viral system. And I know the morning at 5 o'clock, when I was on the rail station, that could be the solution for the connections, and not these screws what we saw in the slide before. And that is so simple now. It's a knot with a dowel, thick dowel here in deonite at the beginning. That's a beech compressed, very hard wood and very strong wood with the conus to find the good point for the next layer. And it's now clear how we can erect this construction layer by layer. And when I showed this picture to the company Hermann, the people there said that is all very simple. Then we build a mock-up for the tender phase. It was not financed by the client. It was a risk, big risk. A mock-up in this area. And with this mock-up, we had the duty to bring these beams on the machines. Here it is the lignomatic. It was developed in 1991. And we had the experiments with these machines, but we didn't have the programs for this project. So we have to write the programs, and we put together the mock-up. With this mock-up, the visitors come to Germany from France. The client comes to Germany, and they were really surprised that we had found the solution to build a system like that. For me, it was a big help that I had now also the people in the company Hermann. They can programize the computer, the machine, and help to order the material. But now you don't have norms for the connections like that, and you are urged to do tests. And this mock-up I showed before was used from the test. And before we tested simple connections everywhere. And when we test the big model, then we had an accuracy of 0.5 of 2%, 2-3%. So we were really with the slipping deformations at the good point. That helped us now to develop a real static controlling, and we need from the geometry, the office from Fabian Scheurer, design to production, to design precisely the construction, to find out the raw pieces for the curved beams, curved and twisted beams, and also to transform this geometry to the machine. That was a big work. It was at the beginning not easy to understand all these problems we had, and also the calculation, the static calculation, get us a little bit problem at the beginning. But with this calculation, you can find out the deformations, strains you have in the pieces, and so you can develop your very good construction with a very good fitting to the reality. And then we started with cutting the pieces. These pieces must be sometimes glued with one curve, sometimes glued with two curves, and also sometimes glued with two curves and twist. And then we cut the rest, and the accuracy of these beams was about 1 millimeter. That you can only do it in timber construction. In steel construction, it's, from my point of view, rather not possible. And Franz Tschimperlin, who was the engineer of this project, now he's on site and explain that this beam must fit at the right place. He must have a number and he must really put there where this number was given by the project. The roof building with the membrane, and now you see one very interesting thing. We had the rendering from Shigeru Ban, and that was built. And sometimes you think that the rendering is always built. But I think when architects have a rendering, we should try to do this in reality, to build that as the rendering is shown. Here the same, the rendering of Shigeru Ban, and that was built. It has been we know that in a good team you can do impossible things. In this team you need a specialist in every discipline. We need a specialist. The architect at left, it's Jean Desgastin, the co-architect to Shigeru Ban from Paris. We need also Fabian Scheurer. He was specialist from the geometry and from the transformation of the geometry to the fabrications. We need the engineers, Franz Tschimperlin, a young engineer, but a really, really good and analytic special engineer. We need also the company Hermann with the chief Gerhard Hermann and his servant Bernhard Tritschler. And to wrote the program for the matrix, it was Martin Pfund. It's not shown here in the picture. So we can learn when we have a complicated project, we first should form a team. Now I come to my first project, 2010 to 2013. Draw it, we build it. I had to say also to me with Helen and Hart. They have an architecture office in Stavanger and also in Oslo. They asked me once, 2010, to come to Stavanger and to give them helps in timber building. And so they started with special drawings with timber. Stavanger is in Norway at the southwest coast, and there's a lot of wind, but it's not so cold here. And the project they planned was the E-Park, an intermediate buildings between two existing buildings from the Innovation Park in Stavanger. And they started with the original concept. And here I showed you the main ideas for this original concept. The existing building once was here and the other of the other side. And here was a go through in a corridor from this building. And the first idea was to build a grid over this place with glass facade, bicycle parking, and so on. And that was Empfang from the visitors for the from this building. Here had to be an openness, and the new building should be transparent and really for the visitors to find also the entrance. And the idea was to have a membrane roof, and then the big problems in these buildings, when you have two buildings and you connect them, that is the fire resistance or fire protections in this area. So we had to plan a firewall at the existing building and hardly discussing with the authorities in Stavanger. Stavanger is one of the biggest wood village in the world, and every 2-3 nights you hear the firemen, they go out to extinct fires in this village. So they are very anxious with the fire protections. At the beginning, they tried to have a roof with a whole membrane, and then they had to reduce the membrane of the inside, and the canopy was covered with plywood. The design for me, it was very nice. I was eager to start my work. Also, the canopy was really spectacular. My service I see as an engineer. So I start with this rendering from the architect, what I have to do to transform these renderings in a rendering of engineers, so that you see the connections, the dimensions, the right dimensions, and you can form a picture for your head, how it would be in the geometry dimensions and how it could be with the supports and so forth. Then the next step is to do really rough static analysis, not very precisely. It's not necessary at this point, just to find out if you are on the good way with your dimensions. And the next you must find out is the connection systems. That is very important. The connections system relies also to the erection on site, also the assembly on site or in the factory. And in the connection system, you have the forces to overtake from one piece to the other piece, and it should be easy to assemble. And that is sometimes not so clear when you work with timber, because we have a lot of possibility to connect with screws, with nails, with glued and so on. And there it's good when you have a good experience. Normally it's also have the advantage when you are carpenter, when you had learned at the beginning, before you study at the high school as a carpenter. In Switzerland, the most engineers had to start with carpenters, and then they finished with timber engineers. Every year we had about 50 young people, they learned engineers on this track. The idea was to use chestnut, but that's a question of price. And you see here, I have one beam who cross in one piece and two beams who cross in the other direction with two pieces, and then you have to connect them at the shear layer here with sharing forces. You can do that with dowels, screws, etc. And then you have very good connections of these two beams, very simple and without steel. At this time, the client is interesting to hear about something about the costs. And so I had to find out which is the amount of timber we used for these constructions, and perhaps also for the covering of the roof when the architects don't have a possibility to work together with at this time with a roof specialist. And so I give prices for the translucent roofing, for the timber, and also for the vertical glass walls and glass doors. But then, yes, we showed that to the client. Nei, that's in Norway, that is the same as no in English, or the nein in German, that you can understand. Nay, it's too expensive. It's not that what we want. All for the bird. The architects were depressive and I had to help them. And we started with an alternative project concept. And now I met them in South Africa 2012 and at the wood conference, and they showed me this new picture of the new project. And then for me, impossible to build it, the rendering. At this time, you should say anything. you should sleep one night or 1 week and then give an answer. They had started with a new project, and the area was a little bit smaller now, and it's a reduced version with the hope to smaller costs. And the construction is very simply, when you see it here, you have to staple boxes one of the other, and these boxes are turned in different direction. But you see, the problem in timber is do not have deformations in the vertical, because we have 4 meters of height with these constructions, and we have windows here and port doors, and yes, and the construction shouldn't move in the vertical. The big challenge is 24 boxes rotated top of the other. And this first rendering were really fascinating, but now we have to find out a way to build that. And the solution was, I went to Ammann in Weilheim to Lignot Trend, not Ammann. This time it was a separated company. And we decided to work with 3-layer blades, spruce blades. And with the hollow profile, we had found the solution. Because we had also a problem of temperature insulation. And now you have to do the static calculation and to connect all these boxes. And how you can connect them, we used screws that my son had calculated that. And the problem was the big canopy we had here, and also the timber building physics. So we had to occupy us with the buildings physics, and I had the help of Andreas Buchner. He's a specialist. And you see the problem is here he has warm, here he has cold, and the covering is dense. And the danger is that you have a condensation here, and we don't have any vapor here in this area. How you can do that you don't have a problem with the condensation? That was really challenge, only solved by an absolute top specialist. Then we started with the fabrications with these boxes. You see these 3 layers with different thickness, and they get to the side. And for build up this construction, we built a shelter, because in Stavanger it's raining 200 days in the year. Really, it's raining almost every time. 200 days, and so you must protect the timber against the humidity from the weather. But this shelter was really helpful, because we worked not as a carpenter, rather as a furnisher. The peoples were coming from Germany because we hadn't the peoples in Norway to build up a system like that. You need very good carpenters to do that. They did it from the company Trend. And in 1 week, they finish, and you see the accuracy of these constructions. Fantastic. This very high amount of screws. Just some pictures, these constructions. And carpenters were very happy to do this work. But once my wife was on site, the construction was not finished. That hold was her question. Are you sure that it holds? Next question. And then there must be a support. I get a little bit angry because I would say that I'm an engineer, it works without support. And at the end, I had the help. I said to her, my son had done the static calculation, and then all was okay. The view from inside, the view from outside, a really quality work from Germany, carpenter. I come to the next project. It is during from 2006 to 2016. You see, it was a very, very long time from the first idea to the finished. We started with the first project, then the money was not given, and then we had to restart, and yes, that's the problem with this project. And it is a project with Shigeru Ban together. He was born 1957 near Tokyo, in Japan, and as young boy, he would learn carpenter, but then he had the possibility to start as an architect. And so he has a good reference to the timber. And he has also a good understanding from static dimensions and timber systems to build. And sometimes it comes with ideas I'm also not able to see the solution very quickly. The project is the Aspen Art Museum in Aspen, Colorado, in the USA. You see here the ski areas. It is a ski resort. And Aspen lies about 2,500 meters above the sea level. In winter, it's very cold here in this area near Denver. And Shigeru Ban don't work with a computer. He only make sketches by hand. often in the airplane. And these catches, these few catches, say all what you need for constructions. 3-4 sketches have all the informations he gives in for his construction. For the facades to clad the timber, the facade, the truss beam with these waves, and here a 3D sketch. You can see it here, this sketchbook. That is about 2011, when he was rendering this project. We saw the facade with these woven wooden pieces, and what you see here is the trusses beam with these waves. The building concept is the museum below, but also the accept of this area, because the skiers come on this height to this building and can go directly in the restaurant here. No, here below the roof. That is here is a restaurant, and here the skiers can cross this, come up this level. And we had a lot of studies of possibilities to find out how we can build this roof with this really high snow load in this area. The first concept was reinforced lap splice with theonite composite materials. So to have chords below crossed with a cutout, then these waves as truss diagonals, then the waves in another direction, then to connect them together with the help of steel medium. But that was not the really concept we go on. Then we had a concept from the engineer from Colorado, from Greg Kinsley. And that is not my way to build, but in the units, the state, they didn't have another idea than to use a lot of steel, and that is not the preference from Shigeru Ban. He don't like steel in these connections. And you see also the amount of drilling and cutting is really high, and the steel costs a lot. Then we went to a third concept, and that was a very short idea I had once when it's a little bit special, because the big problem we have not in the charts that we can solve, the connections we can solve with stoles, but these diagonals are a big problem, because there we have traction compression forces, and in this area where we have to cross these big forces, we have cut out the timber and all these connections pieces, and also this bending here, and that is for the engineer absolutely catastrophic. And what you do, I thought I develop connections here with veneers crossed, and I made the connections between the diagonals in this area glued, and so these waves could be built. But then you must have a mock-up, or you must try to do it. And we could do it in Switzerland. We had a jig and put on these veneers here, and with a vacuum folio, we take out the air, so that get the compressions, and then we could take out the pieces in these forms, and then we cut it with the CNC 5-axis CNC machines. That's not so complicated to do when you know how you can do it. But the problem was they don't have machines in the United States, in the USA. So it was not possible to work with these processes. I brought this piece to Paris, and but we couldn't go on with this idea. Then we came to the next concept, and that was the final concept with care to joints, birch plywood webs, half-lapped joints, full threaded screw connections. You see here the model in an overview of this roof. The supports were distributed at different places, and we had some big canopies. Just to show how this idea will work also with the short crossing, and now with the long wave, not with these short pieces, and they also cross them, and we put on the top joints. And the waves were produced with plywood in birch, Finnish plywood, because they don't have this plywood in United States, and glued together. And it was very important to develop also the connections between the joints and these plywood waves. And the idea was to do it with screws. SFS from Switzerland helped us to calculate this screwing, because we didn't have norms for these connections directly, not in the United States. And United States is a little bit specific with her norms. But also we did here tests. There are some points we need 4 screws, then more screws, 8 until 16. So we could overtake these forces. And the next challenge was to glue the plywood with the right layers, because we have forces in this bending of the waves where we need plywood with the right amount of layers. That we had to calculate and to do it in the right way. And where we had big forces, we thickened the wave. And you see here, perhaps here is a column below, and then it was thicker and thinner, the connections between the waves. You should build a mock-up, because you can learn with the mock-up, and the costs are not too high. And we had a Canadian company, Spearhead, who was able to cut these plywoods, to glue these plywoods, firstly, to build this mock-up on the a very strict control from Greg Kinsley, the engineer of the United States. And you see here the cutout, and here the pieces who is finished as mock-up. So the client can see it is okay, also the visual view. And now we have to test. We had to test the plywood. We did it in Switzerland because in the United States they said we can do it. We tested all this plywood on traction compression and had also some new knowledge with this test to work with plywood where the directions of the forces are changing a lot. The compression was a little bit a problem because these veneers were too thin and they broken at forces we didn't attain. And you see also the elongation of this test species. Then we come to the shop fabrication. The chart with Kertu, that was not a big problem to cut this chart. But these waves were very special. All these birch waves with this gluing with the right compression and the web after gluing, the birch plywood web after the production, and the birch plywood webs ready to ship. Now the site construction. This is the place where we had to start with our roof, ready for the frame installations in Aspen. Scaffolding was done. It was winter, as you see. The first chart layers and the second chart layers is put on. Then the waves were brought by a crane and put at the right place, protected with a paper because the weather was not really not so good. And now all these waves are diagonals are in place. Then a connection with 8 screws. And you see it is winter, 20,000 screws and 7 degrees below zero, hard to work. But they finished, and we were astonished of the good work they did, this Canadian company, and everybody was satisfied. And here the finished work, completed project, now some pictures. The facade, the rendering is absolutely the same as what is built after that. That now is built. That is built. the museum, this exposition. And we had also here a team with the Kyle engineers, Greg Kingsley, with the architect, the local architect also, engineering office in Switzerland, creation Holz in Switzerland, the office, engineering office in Denver, Colorado. Another project, 2019 to 2020, is really a special thing. And next time I had to say me draw it, but we build it from the architect. No, it's not he's an artist, architect and artist, James Tyrrell, light artist. And the project is on the Maldives, on an island, and his project are like this. I will show some pictures. Now first, where it's situated, this project in the Maldives here, and on this island, Fari Island. A very, very nice place. Then I had questions from Markus Tilling, timber concept. Salut Hermann, I hope you are doing well and you are dealing with many beautiful sides of life, including international timber construction. You probably know the artist James Tyrrell, who has become known for his space light constructions. We have now received a very recent request from the Maldives. A new James Tyrrell pavilion is to build there. I immediately thought of you during the construction and the tricky questions that arise. If anyone can solve it, it's just you. That made me proud. Are you interested in looking at this project? Greeting, Markus. Yes, Tyrrell is an international known artist with very, very light, high sophisticated light construction, space construction rooms, and the pieces invite guests to contemplate their own perceptions of form at the immerse the central abundance of light, color, openness, and Tyrrell's scape. Here some projects from him. This new pavilion had the dimensions, and that is about 20 meters here. Canopy, no columns here inside, and a very slim roof, and an opening in the roof. Then I get a study from Poland engineers, and they thought to build that with composites. But these studies were not really congruent with the artist's definitive project. So I started with these failed guidelines. And they studied also a steel construction, but they saw quickly that they becomes problems with the height of this construction, with the deformations, because Tyrrell demanded that this surface from below must be absolutely without any deformations. good, we have not the problem of snow of the Maldives, but we have the problem of high load from wind. And also the problem of deformations of self-load. And this construction was not really good, so they changed to a composite proposal, as we have perhaps by new cars or skis or etc. And this proposal had just the problem that the costs were complicated to calculate and also to find companies who can do that. My first dimensioning I started was with Rhino sketches, and you see here the span of this roof and the supports here, but at the end they were not the same. And the height of the construction. I proposed share pieces here or slides at this point because I had the pre-project from these Poland engineers. And so I thought I could perhaps build that with timber. And then to have to start, it's clear we need a base plate where we can fix these wall panels, oak, and we can connect them with tension rod. That's very simple to do. These panels, I thought I must have a look through. We know that from Ducta, we can do it, and we build sometimes a wall like it, so you can see the outside from the inside. And then from the erection, we need thermal posts and auxiliary supports, and here a main frame or main possibility to overtake the forces from here to a center. But you see, the problem is that here at the end you don't have a support, and is it enough to connect them only this area? But I found out that should be possible. Pieces by pieces is adjusted to the constructions, prefabricated, transport perhaps by a container, because to go to these islands you need a container, and you put that together. That was my proposal to Markus Tilling, but then we didn't hear anything because nobody could say, had the confidence that things like that we can build with timber, and that was really not given. The textile cladding here for the late and all this was unusual, only good for the birds. We restarted with the definitive project. Now we had a new approach from James Turrell, and it looked like that. It's not new with a wall around, but now columns inside. this canopy steel and with the board of the roof with 12 millimeters thickness maximum. I restarted with my studies. We need a foundation. The idea was to have a canopy with the concrete, and this concrete slab with 300 to 400 thickness, and then to have an edge beam to this concrete connected with screws or dowels in the concrete, and then we could fix these columns stiff here, clamp it here to this timber. It's necessary because we don't have any diagonals in this construction. We don't have any slides to stiff this construction. And also at the top, it has to be stiff with the purlins. And to hold the distance, I proposed a steel rod to have every time a good distance between these beams. Now you see this wall is self-standing, clamped on the base, can't move in any way. And you go on with the roof construction, with the beams goes to the center with the core in the center. And you see now the problem, you must have take the bending here. But my idea was also to overtake all the bendings here with the stiff connections here. And so we achieved to support this inner space, to hold this inner space in a really, really good stiffness. We had a door, that's clear, then to have built this also. And then you see the purlins, the main beams, and the inner hole here. After that, a roof with 3-layer plate was put on directly on these purlins, on this rafter. Here's the rafters and the purlins. Here's the rafter. And below, I proposed to put on a ready plate. It is not moving because you shouldn't now see any joints. The cut from this construction and the deformations problem with here, you see this area, the roof will sink down, and with this stiff construction, to start with the concrete slab, stiff connected here, stiff connected here. We can do it with timber, and everybody was really astonished that that was possible. 12 millimeters. Now we have a little bit less, I think about 10 millimeters at the board, and this edge must be absolutely straight. The assembly on site was not done by specialists from Europe. They work from Singapore, but I can say they worked very good, very precise. We had a good experience and that helped me to think that we can work in the whole world with timber when we have preparations perhaps with architects and engineers, and sometimes with companies who has experiment in cutting, and other companies who has experiments in erecting constructions. The roof without the 3-layer plates on. And now I come to the end, and I will show now these special pictures.